All right, so we're on air, so anything you say will be recorded. Just your fair warning. All right, so I'm Kyle Buchanan, one of the organizers. We have two other organizers here, Shashan and Nate. And we just scheduled a new meetup for July 21st, and that will have the original founder of Triangle JavaScript. He's going to be back from Santa Barbara. He works for Citrix. He's going to come back and he's going to talk about real-time collaboration with Firebase. So if you don't know about Firebase, it's great. It's my new best friend. And then other than that, I need to keep promoting NC DevCon, which is September 26th and 27th. I went to it 2 years ago. It's really good bang for your buck. They sold out of the early bird stuff, so unfortunately you'll have to pay the full price now. Which let's figure that out what that is real quick. $200 now. So only 230 tickets left.
If you know a guy, he knows a guy.
Yeah. They'll and I work with the guy who sets this thing up, so I'm going to try to get a discount. Oh,
I'm one of those guys.
Jim Priest.
Yes.
Okay.
Dan Wilson and Jim Priest.
All right.
Yeah, if the company's willing to sponsor, then you can get a free ticket perhaps through your company's sponsor.
Is Red Hat a sponsor?
Yeah, that's a good question.
There we go. We'll work on that. All right, so don't be confused. There was some confusion at Red Hat about it's Cold Fusion. Well, it started off as a Cold Fusion thing. It is now much more than that. Cold Fusion is still part of it. I think it's all sponsored by Adobe. I mean, Adobe's the big sponsor. But it's HTML5, CSS, mobile, JavaScript, Cold Fusion, all that good stuff. And you're still looking for speakers, right?
Please don't.
So if you've got something in that realm and want to present at this, contact you. Or there's a form here to fill out your information. So that's really all I have for sort of announcements. We've got a small enough group here. We used to do this all the time with introductions. So you just kind of go around and say who you are and why you're here. So do you want to?
Can we start?
Yeah.
Cool.
Sorry.
Hi, I'm Edward Ingram. I've been working at LexisNexis and Centennial Campus for the last 2 years as a front-end web developer, and I'm getting ready to leave there on Friday and go be a freelancer / contractor. Got my first client. I don't really have any money though, so wish me luck. Thanks.
So, hello, my name is Łukasz. I came from Poland for a month to visit US, and I'm working for a Fusion company that sent me over. And yeah, JavaScript and web development is my area of interest, so I look it up on GitHub, so I'm here. Thanks.
Steve Worley, just interested in learning more about JavaScript.
Joe Waller, software design. I do node programming with Coursera at IBC, and also I'm working with a company that's doing communication via BitTorrent, and also something of my own that's integrating Node and Julia.
I'm Patrick Steger, currently looking, but yeah, kind of doing the same kind of gig that he is, freelancing at the moment. But I find that my freelance bosses are not as cool as regular bosses, so going back into the working world until I can get a startup off the ground.
I'm Ian Soleil. I realized like a week ago that I've been doing JavaScript for about 20 years. Doing it pretty well, about the last 6. And beyond that, mostly .NET stack, but some Node, and then other little projecty things like Raspberry Pi, IoT, and big advocate of open data, things like that.
I'm Allison. I'm a front-end developer. I work remotely for a computing software.
Terrace, I from IBC and do Node and front-end JavaScript. Interested in robots. So.
Well, you're in the right place.
My name's Tim Morgan. I'm a manager of our continuous integration team. I have an electrical engineering background. I had interest in robotics and things like that. It's been a long time since I touched it, so interested in seeing.
I'm Alex, and I also work at LexisNexis and Centennial campus. I've been there about 6 months, and you know, I'm a .NET developer by trade, but it just so happened that between you know, my current job and my you know, previous job, I've ended up you know, doing more JavaScript than .NET. So you know, I think I've gotten pretty good at it. So you know, I want to learn more about it.
My name is Garrett Jensen. Just moved up here from Utah a couple months ago and just trying to get a feel for the area. I'm working with Knockout and Angular. Just here to make some friends and learn some JavaScript. So.
Cool.
I'm Brad Oakes. Work from home for a large company in California, doing mostly Perl backend, web application and database work, but a little bit of Knockout.js and a lot of jQuery. Also.
I'm Nate Hunziker, front-end developer at Bigot. We're a digital agency based in Falls Church. We've been this year in Durham. Doing a lot of React apps, and big marketing sites.
Xiaoxin Liu, developer at Mercury Gate, and I'm interested in JavaScript and people who are also interested in JavaScript.
And you have JavaScript at yahoo.com, right?
Yes.
All right, that's very awesome.
I'm Kingery. I'm a manager of software development at Light. Developer for 15, 16 years. I don't know. I've been working with JavaScript for quite a bit of that. I also help organize the Angular meetup group, Full Fusion meetup group as well, and the Agile meetup group.
I'm Aaron Mead. I was a front-end developer, but I started a new job at a startup in downtown Raleigh about 3 months ago, and I'm kind of doing full-stack JavaScript now. Angular on the front end, Node on the back end, and I'm just trying to learn. Slightly interested in robotics. So,
I'm Janet Sanford. I have a background in design, but I've been slowly moving more and more towards development. I recently actually quit my job to go back for a degree in computer science.
Very nice.
I'm Mark Reedman. I have a diverse technology background, and I turned on the opportunity to see JavaScript and robots.
And then John's gonna he'll introduce himself here in a minute.
I'm Terry Moore. I work here at Dude Solutions and full stack developer here. Do a lot of Angular and JavaScript.
You're not getting out of this.
Yeah, and I'm Stuart Eads. I also work here to do full stack.
Thanks, guys, for hosting us and the pizza and the drinks. You're welcome. It's always nice. And jobs. I always like to do this. Does anybody know of any jobs that are available? Anybody looking to hire?
yeah, so again, I'm Aaron. My company that I started working for a few months ago is K4 Connect. It's a home automation company. We're building a platform. It's got one of the best founding teams for a startup I've ever seen. And I'd love to talk with anyone who's interested in doing full stack JavaScript.
Yes.
I work for Fidelity, and I don't absolutely positively know that they're looking right at this second, but I imagine that they are. And I definitely can forward a resume, and that's pretty much going to guarantee you to get called.
I work in MetLife, and I absolutely can guarantee that we're looking.
You guys are trying to recruit.
Yeah, I think we have about 300 positions open, or that are going to be opening this year. We opened a brand new campus, actually. The opening, I think, is like next week off of Lake Crabtree. So if you're interested in development positions, management positions, QA positions, we're the full stack of .NET, Java, mainframe, DB2, SQL Server, Turbo Pascal, you name it, we have it. So if you're interested in the job.
And then, well, at Red Hat, we've got some front-end jobs that are open. So if you want to do, I think it's either Angular or React or a combination of the two. So.
Oh, well, I was just gonna say, since so many people are, mentioning jobs that might or might not exist, over at LexisNexis, we just had a guy in my team, leave the company like a week ago, and, and I don't know if they're looking to replace him or not, but, probably, he was a front-end developer.
Okay.
We're looking for a DevOps engineer. I know it's a JavaScript meetup, but I'm looking to hire someone, Google Kubernetes and containerizing, like microservices deployments and things like that.
All right, so lots of jobs out there. And anybody have any announcements, like any conferences coming up? Anything interesting? Anybody release anything interesting?
I didn't, neither of the two, but I'm just curious how many people went to Google I/O.
Nice. We got a brand new tablet, and
I got a sticker for a tablet.
Oh, okay.
I took their tour. Does anybody know what they do at the NC State Google office? I didn't know until they showed it. They write the renderer for Chrome. Nice. Yep. And everything else, all the platforms. So they have a whole big array, and this renderer doesn't work quite right on Android, and this renderer doesn't work quite right on this tablet and Chromecast and everything else. Pretty impressive. They've grown stealthily from whatever they started with, like 6 men to about 40 men.
Has anyone tried Polymer 1.0?
That was one of their one of their talks.
Yeah,
definitely want to.
I've tried, and once again, didn't go so well for me. I tried 0.5, and then I've tried 1. And I tried the whole Firebase element, and
the guy said use 0.9 because it fixes a lot of the problems of the early stuff. So yeah.
All right, John, you ready?
Yeah.
So he's going to talk about robots. Both photography, living robots.
All right. So my name's John Williams. I work for Fidelity, and I do projects like this to sort of massage the soul after arguing with people about Angular and React and all that kind of good stuff. Let's see. I don't want to totally apologize because nothing has gone wrong yet, but I gave this presentation in New York last month, and then hustled home, and everything at the office is crazy town all the time. In a room full of developers, that shouldn't sound strange. And I literally have not looked at any of this in the 30 days since. So, say the prayers to the development gods of your choice. So I'm a front-end engineer, and therefore my slides have to be all animated goodness. Does anybody recognize this?
Yes.
So I had one of these as a kid, and I thought it would be totally awesome to hook it up to a computer. And my dad had this Computer Shopper magazine actually had articles, even though most people just used it as a mail order catalog. And it had this awesome article back in the late 80s that would allow you to hook up a remote control toy to your computer using the parallel port and a bunch of relays and diodes and pretty simple circuit, all things considered. And I ended up doing that project, but I really wanted to hook it up to this robot. And if you ever had one and took it apart, that's not going to work, because these joysticks are not electrical. These joysticks are mechanical. And it's one of the most amazing, I don't think even as an adult I've seen a piece of engineering that cool, and I saw this like as a kid when I took this thing apart. So when you engage a joystick, it's actually shoving a gear into this concentric ring of gears, And when you turn the robot on, there's like this all the time humming from like the main, like the engine in your car just keeps running, and then you engage a clutch and like it takes off. So there's like this concentric set of rings and every different movement of the two joysticks. And there's also, if you see at the top, there's like white circles. Those are like, if you twist the joystick, so the joysticks aren't just up, down, left, right, they're like clockwise, counterclockwise too. Anyway, it was awesome, but you can't hook it up to a computer. But you can hook this one up to a computer. This is the U-arm. There's a Kickstarter. It's from a company based out of China called U Factory. They also have another robot kit. I'm not sure how good it is, but it's like a two-wheel balancing thing. And I thought they were working on something that was like a ball balancing robot or something. This was about $250. And I got in on the Kickstarter. They're making an aluminum model now, which is pretty cool. What you're seeing here, this video has been sped up like way more than the 3 times in the corner, by the way. What you're seeing, there's a suction cup on the tip, which is you can swap that suction cup out with a little grabber, which is sort of what you classically would see in a robot arm. And so when I put mine together, I was like, well, like the grabber is sort of pedestrian and boring, so I'll hook it up with the suction cup. And as my project moved forward, I actually attached, I'll show you in a minute, but I attached some of my custom gear to the little circuit board where the suction cup originally was. This happens. So it changes my resolution when I plug in. All right, so this is the very first time I ever was able to get like even the beginnings of some sort of light painting going on. I just like hooked up an LED to a power source, threw it on there, and started recording through the webcam on my computer, and then used After Effects to get light trails, and it worked about this well. And then I filmed the result through my phone just to kind of get a sense of what it would look like. And if you watch closely, the geometric pattern that is being made here was like sort of the first program that I wrote, and you'll see that program progress as my test program as the drawing itself gets better. So this is that same program, but in a still, and I could tell right away, I didn't have the DSLR yet, so I was like, oh, this is bogus, this is totally not gonna work until I get a real camera. But you can start to see like the red and blue trails at the back are these red and blue lights back here swinging left to right as it draws. By the way, sort of ruining the surprise, but the program that it's supposed to draw is to draw a donut, to draw a torus. And this is like the first one that I got that sort of was close to what I wanted. If you look very carefully, you can see on the right-hand side, which is the side of the torus closest to the robot, it's a little pinched. And that's because my math for polar to Cartesian coordinates was not quite right. So don't believe anyone who tells you that you don't need that stuff. Same program again, but basically with different exposures. And it was about the time, well, actually, no, it's not different exposures. The top picture is like just the light. The RGB LED is, anybody done any electronics? RGB, yes, we all know that, front end, right? So, and then LED, anybody done any electronics with LEDs? No. So an LED is a light bulb that acts as a diode, so it only allows electricity to flow through one way, and when it does, it emits light. So an RGB LED is that. It's got 4 leads coming off of it. One of them is a ground, and then by passing different amount of current or pulse width modulation and all this crazy stuff. But by passing different amounts of current through those other 3, those are your red, green, blue, and you can programmatically control the color of the light. The bottom picture, I realized like, oh, I'm blowing out the camera, like it's too bright. So I took a piece of black construction paper and sort of poked a hole and was sort of trying to control the amount of light through that. And it was like really tedious, and I couldn't get the exposure right. It depended on, well, how fast is the robot moving versus what's the exposure settings on the camera. It was this like total nightmare. Cool. But it was enough to get a first Mona Lisa. So this was like the first picture that I drew where I was like, oh, this might just work. And I started joking with some friends on Twitter about how digital artists are required by law to use the Mona Lisa for demos. This is the same program, but, well, actually, it's, let's see. So that first picture, see how it's sort of like jaggedy and on sort of a weird angle. The light is pointing out this way from the robot. So this robot can, if I do my body sort of as a metaphor for the robot can do this, and it can do this, and it can do this. And if we didn't have this on here, which I'll talk about later, it could do this. It could twist a wrist. So in here, it's drawing like each row like this, but it's staying the shoulder, like the main rotation is staying fixed. In this one, I decided to flip it around so it's drawing like this, and like the amount that it reaches out is fixed, to see if it would give me a little bit better, like you see like gaps in between the rows and the jagged edge, like in terms of like the vertical. So I still get sort of this stair-stepping effect that I tried really hard to make go away. And just, I think it's just mechanically like the robot just can't do that. Which means that, you know, there's that idea that the limitations of the technology that you have to work with sort of drives creativity. But I messed around with like, what if I could fill in those gaps by making the robot arm sort of paint in waves up and down as it went across. And this was not what I was expecting, but it's my favorite picture of the entire series. I call this Glitch Mona.
Mona Glitcher.
What's that?
Mona Glitcher.
Mona Glitcher. Nice.
Do you know how many rows? I mean,
It's not. It's like in the neighborhood of 60.
So how long of an exposure time is this?
Like 2 minutes-ish, maybe 3. And then some, but not all, but some of the weird little bright spots are noise. This is an attempt at Starry Evening, and it was like 2 in the morning, and I basically took this code and I changed the underlying PNG and I just ran it. We're gonna come back to Van Gogh. All right, so this was the circuit board where there's a module for the suction cup, and this right here, I don't know if you can see it from back there, but this is a limit switch, so that when you've got that suction cup on there, and then you tell the program to like try to go through the table, it doesn't like screw up the servos. So this was attempt number 1 to like properly mount the LED, but that limit switch is more the center of rotation for that wrist control. So things are about to get tricky. So what I wanted was an iris to control oh, I'll make one, which is like a classic software guy trying to do hardware. So this is little flaps of construction paper being glued to little pieces of like a stiff wire that I bought at the hardware store years ago, and it's just been sitting in my toolbox. And then like the stack of quarters is weight so I can let that dry. So what's going to happen is the part that's sticking up is where it's going to swivel. And this was like attempt number 3 at getting that mechanism to work. And I was like, oh, awesome, I'm almost home. No. So when I hooked this up to like sort of the broader physical reality of the robot, it would like bind up and, you know, because it doesn't have like a insanely complex human controlling, that it seems like it's doing what it's supposed to do, but it's just not like mechanically there yet. This is like attempt number 5, but now you can see that's I'm just running a little program that's stepping the there's sound. That was the music that was playing at the time. There's a program running that is just stepping it up to a certain amount on the wrist control, and then back, and then up, and then back. You can see that it's held together with hot glue in the corners, so little pieces of wood and a little piece of scrap acrylic that I sort of, drilled holes into and used a Dremel on. And that actually is pretty much what's under here. And the black sock is on there. It actually probably helps hold it together, but you get really bad reflections off the acrylic. So and like the light will like hit, refract, and then travel out to the edge of the acrylic, which is the same principle that some old touchscreen technology used to use. Actually, frustrated internal reflection. Look it up. It's awesome. Okay. Drawing a star. This is like a first test with now like the iris is in place. So everything that you saw before was like completely rigged together with, I'm gonna mess around with a piece of construction paper with a hole set to appropriate size. And actually that was still getting, the light was blowing out, and I ended up using, if you've ever done any electronics, the anti-static bags are like sort of see-through, like they're kind of tinted. I ended up like taping a piece of plastic of that stuff like up in there. So I'm trying to draw a spiral, and then I'm setting the hue. So if you mess with RGB, you can also mess with HSB. So the hue is a value in degrees. If you've ever been up inside Photoshop's color picker. So what I'm doing is like whatever angle I'm at from the center, I'm setting the hue based on that. It's 100% saturation and brightness from there. But you can see like, it doesn't really, like, I know that the math is right, but it doesn't really, it's like kind of squarish, for a spiral. Okay, so this is, and I'm going to blank on the name of the algorithm. There's a guy who figured out a mathematical model to describe that pattern that you would see in a sunflower with the seeds. And it's the short sort of explanation of the algorithm is you start at the center, and you're gonna increase your radius every time you step, but every time you use what is it? It's a
Fibonacci.
Yeah, well, so phi, which is based on the Fibonacci, or all that math is interrelated. But yeah, you step the golden ratio of degrees around the circle every time you iterate, and there's and then the distance that you drive the radius out is like the square root of, I don't know, distance traveled or something like that. There's like a square root in there, but it's not a perfect circle because my robot has Parkinson's. It and apologies if any of your family members have Parkinson's. I thought about that joke and I'm sticking with it. So it's like when you tell the robot what coordinates to go to, the shoulder sweep is in degrees, so that's cool. But the guys that, and by the way, there's no documentation for the underlying driving code, and they're Chinese, and you can email them and they'll answer you, but so they use degrees here, but for this and this, they use height and reach, which is Cartesian. But then, and that's what you pass to the robot over the data line. But then if you look at their firmware, it goes back to it has to go back to degrees for the servos. So I think there's some messy stuff in the what do you call that? Double float precision where it loses like a couple of decimal points and there's just certain spots it can't get to. I thought it was like you see, do you guys see this?
Yeah.
Like that's an insane amount of wiggle. That's like 10 millimeters up and down and probably twice that left to right. So I figured it was that, which meant it would just be slop in the system. It's if you've done 3D printing or like CNC, it's called backlash, which is kind of a similar notion. But it's not like if you run this program over and over and over and over, and like that Mona Lisa that we looked at that had blanks at certain spots, they're almost always at the exact same spots. So it's like there's something else going on. If anybody $100 bounty to anybody who wants to find that for me and fix it. Same program, but with the attempt here was to increase the size of the dot that it was drawing as you went from the center outward. So like the gaps here, the idea was like to make it less like small points at the middle, and then sort of increase that as it went out. It kind of worked. That's the last one of those. All right, getting the gusto, I promise. So when I gave this presentation in New York, every presenter had 10 minutes, which is crazy. And so now you're getting like everything that was in my head like a month ago. Sorry. All right, so then, and apologies, this is coming over the wireless, even though it's meant to be served from my local machine, and I never compressed all the images because it was meant to be served locally, and I couldn't get that to work. This is the logo from Bang Bang Con, which was the conference I was at, and we'll take a look at some of that in a minute. But this is actually drawing an SVG file from Illustrator. Super cool. Okay, so this is I took an SVG file off of Wikipedia that's a map of the planet, and I traced like all the continents and dropped in some latitude, longitude lines in blue, and then programmatically wrapped it around a sphere. Which means that even though the robot has Parkinson's and it's very difficult to tell what's going on, Africa's in front, just to the right of center. But part of the sort of confusing nature of things is that it's actually drawing the back of the planet too, so you're seeing like through the planet. I want to say India is about the center of this image, I think. Or maybe that one, I don't know. Let's see.
That looks like
South America, bottom right, North America, upper left. And I was like, what? That's not right. And then I looked at it like a globe and I'm like, no, that's pretty legit. All right, so, I wanted to do animation, and when I was doing the individual frames of this, it was like 3 or 4 in the morning, because you can only get this kind of high contrast with every fucking light in the house has to be off. And even then, like after about 3 minutes, 4 minutes maybe, the amount of noise entering the camera just like destroys the shot. So I was like, if you looked at an individual frame of this, oh come on, like it's garbage. And I was like totally pissed, but I was like, well, fuck it. I have to get on a plane, and you're gonna have the animation you have, and so I just went ahead and generated it. And it's interesting how like your brain just kind of fills it in. Okay, so this is an STL file, which is a 3D format. Let's see. Okay, and then I wrote code. Sorry, it's coming back to me. I wrote code that in an STL file, it's going to go through all of the geometry, which is going to be like all of the different polygons. And then I ended up with like all these weird diagonals and stuff, because in an STL file, everything's a triangle. So then wrote code to determine which triangles are coplanar, share a plane, then figure out what edge it is that they're sharing, and delete that edge in both triangles so that you don't get the diagonal down the middle. But that still doesn't account for the shared edges, like 2 faces that are sharing an edge like this. That edge is shared. So that's just like a loop through the whole thing, and you just delete one of them. And then got to have some fun with matrix-based 3D rotations to generate the spin effect, which is kind of fun. Okay, so if you remember the Mona Lisa that had the gaps, I had this idea that was like, okay, I'm gonna get rid of those gaps by, I'm gonna draw the red channel along one bias, and then I'm gonna draw the green channel along another bias, and then I'm gonna draw the blue channel in these rows along the other bias, and it'll sort of add up. And this is attempt number 1 that didn't work. This is attempt number like 10 that kind of, sort of, maybe, but didn't work. And this was like, yeah, this was like, you know, I don't know, show of hands, better or better? Number 1 or number 2?
One.
Yeah.
One looks
Yeah.
like Van Gogh did it.
So this one, like, the iris is set smaller, but the step from row to row to row is like a higher distance. And then this one, like, the iris is opened up a little bit to make a bigger brush, if you will. But I was totally disappointed. All right, so this is an attempt at, remember the sunflower pattern with either the ring or the big disc? So the idea here was I'm gonna use that same drawing pattern, but then I'm gonna look inside a PNG, find the color that would be Van Gogh's sunflowers at that location, and then paint a dot that color and repeat. And it didn't work. This one, like, thought about working, but something weird was happening. This is like another, like, happening at 4 in the morning before I'm trying to get on a plane to go to the presentation. You can kind of see, like, the vase is down here and the table's down here and the background's blue. But it's like, as it was sweeping across, it was almost like it got stuck. But I sat there and watched it the whole time and it wasn't getting stuck. So this has sort of been one of those interesting projects where, you know, you learn a lot where things fall apart. We'll skip that. All right, so let's, like, do a demo because that's what people want to see, right? Well, I want to show code. Let's show code. All right, so okay, the code that lives on the Arduino that's on the robot itself is C, which sucks because I hate C. But the stuff that the company, like, sent as their working software is pretty close to what I've been using. It's very lightly modified. All this is on GitHub if you want to take a peek. But I did want to show, like, what's the secret sauce between. So all my code is Node. So I want to show you sort of what the secret sauce is of getting your data from Node and then into the right format, which was bare, and then, like, across the wire in sort of this reliable way, and which was cool because I got to learn something about how people design these systems. Let's see. So everything uses a serial library, which, like most stuff like this, is going to use a serial library. So that's nothing particularly special. And then my computer at work scrolls one way, and this computer scrolls the other way, and I haven't got them synced yet. Okay. They wrote a UARM library, so they have a UARM API, which is how you set the speed of the servos, how you tell it, like, what coordinates you want to send it to, that kind of stuff. And then inside of that is a library that they're piggybacking off of, and I'm pretty sure they've modified, called var speed servo, which you can Google and find information about, like, the guys who wrote that. So each one of the servos inside the robot arm are a variable speed servo, and they create an object for each joint. And the internals of the UARM library use the var speed servo. All right. So there's, like, some initial setup, but that's not the interesting part. All right, so anybody done any Arduino at all? Okay, so Arduino, like, from a programming point of view, tends to piggyback off of processing. Anybody done any processing? Just hoping for more. Okay. So it's a tie. All right, so if you've done any processing at all, sorry, this loop will be familiar. You don't have to, but processing programs, like there's sort of a, what do you want to do for setup? And then there's a loop, and it'll happen basically until you tell it that it's done, and then it'll like fall out the bottom and quit. So, and it takes care of like how often should the loop run, and the timing, and sending interrupts to chips and all that stuff. So, anybody used a state machine before? All right, so this is a state machine. So what we're going to do is we're going to read a byte off of the serial port. Selection's not working. It's awesome. And then based on are we in state 0, state 1, state 2, state 3, we're going to do different things. And this looks kind of gnarly at first, but really all it is we're looking for a certain byte header that sort of announces like, a fresh command, right? And so they've defined that as being, it's going to start with essentially 255 is what's happening here. So if you do a little bit of hex in your head. So if it's in state 0 and it reads, and I'm not going to go through the whole state machine, but you'll get the idea. If it's in state 0 and it reads this particular byte and only this particular byte, it will change the state machine now to be in state 1. That sequence of the loop will just fall out because it's just going to hit else's all the way through. You come back to the top, you're going to read another byte. If state machine is 1, which is what just happened, we're going to look at that receive byte. Now we're looking for 66, which I don't know what that is in decimal. 120 something. Anyway, go to state 2, and this is where sort of like their code and my code diverges. So they basically had only one command, which is tell the robot to go to a certain coordinate. I modified that to have a couple of different commands. I want to be able to set the speed of things or go to different coordinates. So there's some additional, and this is easier to understand from the Node side, so I'm going to kind of skip the rest on the Arduino side. But, so this is the block for setting the servo speeds. It's a little bit easier to look at for, so what we do is, then things get interesting. What we want to do is we want to read the next 8 bytes, and then like in 2 byte blocks, those translate into all the different things that we're looking for. So they set up a counter, and they read all that into a buffer. Again, this is all happening 1 byte at a time. And you kind of see this, this little pattern happening. And there's some bit shifting nonsense that took me a while to even begin to reverse, not even reverse engineer, just like vaguely comprehend. So if it looks like Greek to you, that you're in good company. But you can kind of see how the first 2 bytes are going to drop into the rotation temperature, the next 2 bytes are going to drop into the stretch temperature, the next 2 bytes, etc. Anybody bored? Okay, good. And then we're going to call set position on the UOM, right? So let's exit from Arduino as quickly as possible. All right. What's this? Where are we? Not there. We don't want to be there. All right. So the first like 15 programs that I wrote, it was like the worst JavaScript you've ever seen. There was no sense of libraries. It was just like brute force, top to bottom, you know, old school. I just trying to get some stuff done, right? And then it's like, well, if I'm going to put this on GitHub and I've been doing programming for 20 years, okay, I should probably like drop it into a library. So should I make this bigger? I don't know if you can see this tab. So this is my like JavaScript UARM library, and it's kind of meant to mirror what's happening on the Arduino side. Let's see, and what I wanted to show you was, so start with the serial.
Can I ask you a question?
Yeah.
Where I'm a little lost on the connection between the C stuff and the Node.js stuff.
So that's exactly where we're going.
Okay.
Yeah. So in the same manner that the Arduino code was using like a third-party library for serial to be able to have access to those bytes, and then now it's going to go off and do something with that data. In exactly the same sense, in the Node world, there's an NPM module for serial, which is awesome because you don't have to write that stuff yourself. So this should look familiar if you've done Node. We're going to grab this serial port library, and this object apparently gives us access to all of its methods. And let's jump, and we're going to create one. So the port where I'm saying that the Yorm robot lives is wherever I say the port is, which is like that's a whole thing. I can talk for half an hour about the audio configuration of trying to figure out, because I've got, I don't know if you can see this, but I've got 3 USB devices plugged in. There's an Arduino in the robot. There's an Arduino only driving that RGB. And I've found a library that poorly lets me talk to the camera, so that I can say like, start the shot, start the program, end the shot, and then transfer the image back, which is super cool. And all of them are serial based. All right, so we're gonna open that port, and then, so the secret sauce is that's listening for data to come back. That connects the RGB. Hang on, I'm looking, here we go. All right. The secret sauce for talking to serial is that object that comes back from creating the serial report, you're gonna call the write method on it, and you're gonna pass it a buffer. And the buffer is gonna be your data. I don't know how many people use buffers in Node like all the time? So, and then how many people use Node all the time? There's like, I'd say 1/3 of the people who've used Node have used buffers. So I hadn't used a buffer before, and I knew that it was important for streams and stuff, and this was sort of my first foray into using buffers. It turns out it's pretty easy though. So what I've done is, let's go back to the top. I made myself essentially some constants that I'm going to use over and over and over again. And remember I said that on the Arduino side, it's expecting a certain byte header sequence before it receives its data. So the header for setting the position is that same OXFF byte followed by that OXAA byte. I've got one in here for getting the position. If I send it this sequence, it'll send me back JSON, because screw bytes, like no. So I actually have it sending a character at a time of JSON, and then ending with, I don't know, either a null byte or a \n, and then I'm like, oh, that's a full JSON payload, turn that into JSON and do something with it. I can set the speed with this one, and I can set I'm running a variation of the same program, but on this Arduino to drive the RGB. So I just stole that whole state machine idea, except I gave it a different header sequence. So these are sort of my header buffers, if you will. And then when I'm getting ready to write, I just make a new buffer where I concat that array with an array that builds up all the different angles for all the different servos. And in this case, I'm dropping like a footer byte, like just a 0 on the end. I don't know that that's necessary because the state machine should fall out to the bottom, go back to the top. Because I think once it's done what it's done, it sets the state machine back to 0 every time. I'd have to look. So this shouldn't be necessary, but it was like one of those stray pieces of code that gets left in there because, well, it's working right now, so. You do it. You do it. Let's see. Any questions on the code side? We'll run through a demo. I'm sure I'm way over. You want to let's see it run?
I had a couple questions.
Yeah.
Are you modeling the system kind of on the JavaScript side, or are you querying positional data from?
It's not really that complicated. I'm just. So all of the programs use sort of a very similar structure. Let's see, I'll bring one up. Let's draw SVG. Here's the one I'm going to run in a minute. So there's kind of all this setup for dealing with the arm and the camera. Anybody use Paper.js? Paper.js is an awesome library for dealing with like Bezier curves and SVG files and all that kind of stuff. And you can say like, I've got this path. I want to know the length of that path. I want to know the point that is along that path, but at the 12% mark, so you can like walk along it. Really, really cool. Anyway, what I do is, so some things are going to read 3D files. Some things are going to be like purely programmatic, like the sunflower sort of design. This one is an SVG file, so it's gonna read that file and it's got like its own data structure, and I'm gonna walk along all of the paths within it using this function, and this is the function that's called inside that one. And basically what's going to happen is I'm building up a list of commands as I go, which are things like tell the robot to go to a certain coordinate, tell the RGB to be a certain color, tell the robot to go to another coordinate, tell the light to go dark. And it's just going to wait for 200 milliseconds. And the code is designed so that one of those will happen. And in some cases, like with setting the color of the light, you basically can immediately say, call next command. But some of them, like going to a certain coordinate, it goes ahead and puts itself into a state where it's waiting for the robot to say, like, I have achieved that coordinate before calling the next. So what you end up with is like this huge array full of these drawing commands. Who's used, and this is the step function that then, like once you've built up that array of commands, then you call step, it pulls the first one off, runs it. But no, I'm not. And is anybody familiar with the term like inverse kinematics or kinematics? So it has to do with like, how do you translate these angles of these joints into like the position that happens after you chain like 3 things together? That math is really, really gnarly, and it's embedded like 2 layers deep in the C code. So I really was clever about avoiding having to port that mathematics back out of the C into JavaScript, because I wasn't convinced that I could do like inverse cosine, like, and there's like some power rules and some inverse trigonometry stuff, and I wasn't 100% sure that I could do the inverse of those functions and like actually get it right, given that if your theta is outside of a certain range, then that function is no longer valid, and you have to like think about all that. And I was like, fuck it, no. Anybody who wants to talk about like how I did deal with that later, we can do that. Anybody use promises? Yeah, so use Q. Yeah. Booyah, Q. So what happens, I'm using promises for the initialization step, where I've got to make sure that I have connections to all the different pieces of hardware. So I set up a promise for each one, and then when they all resolve, like, okay, now it's safe to start, which I was particularly proud of. That was fun.
Thank goodness we're not done.
Yeah. That's the whole thing. That's all. Oh, God. They say that ES6 will save us, but I think they are mistaken. All right. Well, that's the wrong folder anyway. All right. So let's run it. Can't see that at all. All right, so what I'm going to do is I'm going to run that program, and before I do that, I know that the camera goes to sleep.
Would it be helpful to kill the lights?
Yes.
Kill them all. Kill them all.
Is that enough or you want more?
That, we should be all right because it was like moderately visible earlier. And I tend to leave a lot of debugging like console logs in my code because I'm a savage. So you're gonna see like some of that happen as this goes. Hopefully. So you can see like the step function is pulling the next command off the array. You see setting color going through. While that's doing that, oh, that is too bright. Oops. Okay. So let's, oops. Said that worked. So this one. All right, so I was in New York, so I did the I Love New York thing. That's from, and that, you can see this orange wall, that's a legit picture. All right. That came out better than the one I did there. Do I have one? Yeah. Okay. So that's this guy. So those are, you're seeing the individual, of this?
No,
of this? This is, you're actually seeing the individual points. You see what I'm talking about?
Yeah.
Those are just the, so if I do this.
Did you trace that?
No, like those are the handles.
No, I know that, but was that a tracing?
No, so I pulled that from, like the I Love New York is so famous. They've got like a vector image, probably, it was probably from Wikipedia, and then converted it to SVG in Illustrator. So what I was going to do is,
The issue is like, I don't think that should have that many points in it.
well, I mean, it's just an artifact of whatever they use to create it.
Right.
And then this doesn't know how to like draw text, so it's going to be like text converted to outlines. So what I wanted to try was, since this is Triangle.js.
We were just going to ask you to do this.
Yeah, cool. All right.
Nothing better than a live demo.
I was going to say, you got to have a live fuck up. So I can't remember. Is it? I can't remember. I think it's. I can't remember how whether I left it as stroke or fill. We're gonna go with stroke. Oops. See what happens when I. No. Oh, I gotta rotate. Right. That's not right either. Oh well, we'll get something. Oh, I see. Something like that. Yeah. All right. I'm sure there are better Illustrator people than I. All right, so let's save that as SVG. Overzealous. And we're gonna, because I'm also a savage, this is hard coded. And let's run it again. Is it changing color?
So when it draws, is it doing it's doing a grid pattern, like left, right, up, down?
No, it's actually following the vector.
So it's going to follow a vector shape.
Yeah.
And then do the next shape.
Yeah.
Okay.
The Mona Lisa that you saw, that was raster. That's like I took a Wikipedia image and scaled it down to like 50 by 60. Well, okay, so.
Yeah, colors were all white.
So maybe it was Phil?
Success.
Whoop. Whoop. So, yeah. There we go.
That's not white.
I knew whatever I'd done was backwards to what I should have done.
Why does it have that little blip in there where it has a black color?
It's moving from one shape to the next shape, so it has to be able to travel without the light on.
Gotcha.
And that was actually one of those things where, like, I knew I needed to do that, and you would think that the flow control in the loop would make that like fairly easy. But it was amazing how nasty the code like looks in terms of like you have to insert it at this weird place in your loop, and it makes your loop look ugly when you do it. But what was I doing with that? Yay! So if anybody's got any SVG files, they're just dying to have Lightpainting.
Could you like compare both of those at the same time?
Oh, yeah,
If they have the same artifacts.
It looks like it.
Yeah.
Oh, that was dumb to do that.
And,
Yeah, you see that wiggle on the left?
and on the right.
Yeah. Well, yeah, on the blue one and then on the green one. It is.
At least it's reproducible Parkinson's.
And then like this point is high. Yeah, no pun intended.
So it's moving all three axes of what it's doing.
In this case, is it moving off? In this case, I have to get back to you. I think, yes, it is. So there was one version I did where it basically is going to paint along a curved surface by keeping this distance constant. But I think it does actually like do the polar transform to reach in and out, so out in the corners and then come back to the middle and then out, right? So that plane of drawing is flat.
I wonder if it's an amount of mechanical bind. When those 3 points at a certain grouping, it would cause more friction, and it has trouble like bypassing that friction. So as it gets close to it, it sort of stumbles, and then as it gets to the other side of that friction point, it lets go. Or that, or the fidelity of the pattern it's following, right? If you're the upper left, like how many dots it makes per triangle. The combination of the two is weird.
Yeah, but it's the same shape, like copied and pasted in.
It's the same shape, but again, because of the three axes, the arms and the gears are all in a different place in each one of those points.
Yes.
What you could actually do is if you shifted all three triangles about an inch up left of your image and then reran it again to see if the artifacts appear in the same location.
I love this.
Okay, fine, the right, whatever.
Oh wait, which way? No, which way?
We're not getting specific here or anything, but
No, which way?
yeah, that's better. Thank you.
That works.
Yeah,
Up, down. Good.
No, we're good. That's
Good.
good.
No, I'm not.
Did you say it?
I think so. So that's the other thing about this is like,
Numbers are way.
you know how they say like, who does test-driven development? Yeah, screw that. So you know how they say like, if your test suite takes like too long to run, then you'll not bother to like make it a part of your build because you're like, fuck that, I just want to like, I'll try it manually because I don't want to wait the 2 minutes for my test suite to run and then that messes with your whole. So like, this is such a slow iteration time, right? Because like, no matter what you do, you're gonna have to wait the 3 minutes for the thing to draw. So like, I'm so used to in front end code being able to iterate like really, really fast, you know? So console log some stuff, run it again, you know, refresh the browser, like take a look and like be able to iterate really quickly. And like this means that when it's 3 in the morning and you're like, oh, I'll sleep tonight, like you're only gonna get like 20, 30 more iterations in and then you're done.
Same. A little different.
Yeah. Yeah, so this one's this flat here, but it's about the same otherwise.
But is it farther over in the
I think so.
The numbers look way different to me.
Did they?
I make a suggestion.
Oh, you know what? The code centers it up.
Oh, wow.
I think it
You've ruined everything.
Because it's a feature of Paper.js to be like, tell me the center of this group, and I'm subtracting.
Problem solved.
So
add a single dot in the bottom right hand corner to set the frame of reference, and then move the entire object up to the left in the second corner of that right that dot towards it. Or draw a box around. Let's see what that is.
With regards to your Parkinson, is it possible? Oh, they said it.
I did. No, and don't apologize.
Is it possible that maybe, as Mike here is saying, is that as the arm is extending and moving about and it's getting ready to hit its actual point, when it begins to pause to hit that point, that the base of the unit might be shaking or the table's not stable? Is there any way you can stabilize anything extra?
It's pretty sturdy. I mean, so it's got 4 suction cups on the bottom.
Right.
I mean, remember the image where like the right-hand side, it was fine on the left, and then on the right it was all grouped up.
Right.
I'm convinced that was like slippage on the table. Maybe. Oh, that doesn't make any sense either, because then it would be like all over the place.
Yeah.
I love these like group troubleshooting sessions.
Well, you offered $100, so
that's true.
You missed that part.
That
anyone that can figure out is
that
$100.
that stands, man.
So you mentioned front-end tools. What would library look like for this?
I don't know.
Take the old SVG and transform it.
The other problem too is that like, depending on how you set up your workspace, the environment is so sensitive to light that how you have your laptop screen setups will bork the shot, which means, and then like, you know, it's a Mac, so there's like the keyboard light, and I was like, I was doing, and your eyes are trying to adjust to the lights in the room constantly going on and off as you like walk around the kitchen table and try not to trip over all the cords you've got set up.
So you use an Oculus or something.
It's different.
So now move that star much farther down to the right to force the rest of the image.
Let's do more.
move diagonally as opposed to just.
I'm really pleased with how like forgiving the whole, like I've set this up a couple of times at home and it'll just be like, can't find your camera, can't find your robot. And it's been flawless, so that's really awesome.
Can you adjust the speed of the robot?
Yep.
You can adjust the speed of the robot, so sometimes it'll do the picture quickly, sometimes it'll do it slow.
And for this particular program, that has more to do with the node program being told to step through the number of steps along the path. It has more to do with that than it does with the actual speed of the robot. Though that does matter. That can get tricky too. Like it's interesting, like if you get really down in the weeds of what's happening with the data going to the, not just going to the robot, but going to the servos, read up on pulse width modulation, because that's what's like really happening there. If you dial the speed of the robot down like really, really, really slow, you get some really weird effects with, if you change all three coordinates at once, but it's not an equal distance for each, it'll like basically do nothing, do nothing, do nothing, do nothing along one axis, and then all of a sudden at the end decide to like move the remainder. It's really, and because I think it's just like trying to, well, I don't know. It's C. I don't want to program in C. That's the whole problem.
So is that what they'd be doing, like in that artifact in the corner of the writing where it's saying?
It's possible. So the other thing, I'll show you something in a second.
$100.
I'll show you
I think it started over a couple times.
Really?
Let's say it's got to be done by now.
Well, that's a problem because it's not going to kill the shot.
Will it just redraw over itself?
It's going to be super brief.
What? What? Oh. What? Is it just doing the star over and over and over? It is.
Yeah.
Yeah, so that's the rise of the machines right there.
Skynet. Right? That's how it starts.
But it's not going to return. How do I do that? Get. Where is it?
Did you save your file?
Yeah. I think one of these programs is supposed to be to grab the most recent image, but now I don't remember which one.
It's called Get Last.
You have better eyesight than me. We're just
That was the log that says Get Last.
It's not. Did I not separate that out into a separate program? Damn it. Yeah. Okay, then we do it this way.
Skynet's not happy with you.
We want to make sure we got the star. LOL.
Oh, I don't remember where it's going to go. It's such a bummer. Okay, I see it.
Does the star have like a million points in it or something?
I don't know why. It went into some like infinite loop over that. I don't know why.
So it looks like it's the same art. Yeah. So it's okay. Yeah, similar but different.
So the bounty stands until claimed.
so obvious, half obvious, not the question. Why? Why did you choose light? I guess it's more.
Okay, so it depends on how far you want to back Y up, right? So because it's a series of poor decisions. And I think that's why the presentation does. Oh, I forgot to show you guys something. So that's why the presentation starts with the Armatron. Is that like when I saw the Kickstarter, it tapped into some childhood memory and they had me, right? It was like if that robot was less than $400, I was buying one. And I knew the minute I gave my credit card, I was like, this is ridiculous because I don't have any idea what I'm going to do with this. And I knew that, like, I'm like typing it in and I'm thinking about how I don't have a plan at all. But I have a 9-year-old boy who's interested in program. I can't tell how interested he is in programming, and like I'm interested in programming because my daddy is interested in programming. But I figured like, oh, I'll have this, and I don't know, I'll figure out kind of this node thing that I figured out to help him. And it'll give him something tangible, because like so much of computer programming is like the fucking box, you know, it's boring. Like unless you're like really into the graphics of it, and then there's so much about programming that you have to learn before you can learn about graphics. So I don't really know where so maybe to answer the light painting question, I'll show you the part of the presentation I skipped. It's only like 2 minutes if anybody is like, God, shut up. Fine. There we go. And hopefully this will, okay. Does anybody know this? This is Hector. The guy who did Paper.js did Hector. This is a spray paint robot. And then look, the fidelity is amazing. This is the same guy, but doing chalk. This is called Victor. This is within the last couple of years. I emailed him and was like, dude, love your work. You've open sourced like the Paper.js stuff. Care to open source this? And he like very politely didn't say no. You know? Anybody seen this? This guy's my hero. Oh, what's his name? Well, he didn't publish his name, as you're about to see why.
Sweet. That's rules.
You should just do that everywhere.
Anybody seen this? This is Bot and Dolly. So what's happening here? These are, you recognize those robots in the back? So those are like the industrial grade versions of
cars.
This.
They are so expensive.
They're wickedly expensive. This is a digital effects company in California. Google bought these guys like 3 months after this demo came out. Hang on, I want to pause this and talk about it. They are, anybody like messed with or heard of projection mapping? So you actively think about the 3D space that you're in. They've programmed the robot so they know exactly the motion that those surfaces are gonna make through space, and then they're projecting across the entire space. But then they've masked it only to the objects they know they're gonna. And the whole thing is like this complicated dance, you know, in Maya or whatever they're using to program it up. And then the camera that you are watching the scene through is also programmed so that the perspective is perfect. So they'll pan the camera you're watching to the right as the projection onto those surface changes to match that perspective. Like insane. All right, so these guys went into Maya and they made like these 3D shapes. And then they wrote a Maya script that basically is like a virtual CAT scan that sweeps a plane through the 3D object, creating a movie file. They load the movie file onto an iPad. They do the same thing I'm doing with long exposure photography. They hit play on the iPad and they sweep it through the space where the camera's watching. And then what you're seeing here is a frame-by-frame animation where 3 guys have done that over and over and over and over and over again, and they're wiggling the iPad as they sweep it. And if you Google making feature magic, there's like a whole video that they made. There's like a little dog in a garden. It's like this glowing little like robot dog tweaking. This is the pixel stick. So it's this like row of LEDs, and you can load GIFs onto it, and you hit a button, and it'll sequence through the columns. And so you wave the stick, and you can paint. That was straight out of the 80s right there. You can paint these you can paint these patterns in the air. You can kind of see what's happening here. I think you can load animated GIFs on it. Those guys are out of Brooklyn, and you can buy. It's another Kickstarter. I haven't bought one, but so these are some of the projects that inspired me over the last 10 years or so, and I think you can kind of see some of the threads coming together into a project like this. Embarrassingly enough, I figured like this was such a ridiculous project that I didn't think to look whether anybody had done it before. And so I got home, it's like, oh, well, the presentation went well, that's cool. And I just like, it was totally like ego surfing, I guess. So I like wanted to see if anybody had said anything about it. So I just Googled like robot light painting and found like 4 or 5 projects from people who had done, there's one guy who had done this, it's like a $20,000 industrial robot and basically done the same thing. Except I think what he was, if anybody's messed with Kinect, which can like read 3D space, I think he was like reading 3D space, and then when he painted, he didn't just paint onto like a plane, he was painting like, and doing these portraits of people, but it's like a $20,000 robot.
Was he also light painting?
Yeah, well he wasn't, that was the thing that like kind of blew me away. He's got like this amazing piece of like hardware, but as far as the result he's painting, it's like dot, move, dot, like, you know what I mean? Like very like raster looking, but he probably like he's not doing any vector following or anything like that. Then there was a guy who like, he made his own little, it was just like this little, it makes this look very professional. But he built his own robot, and it was like, I think it could twist, and then he just had like a blue LED essentially on the end of a stick, and he could like do this number. I don't think he could control like the radius of that sweep, but he could turn the robot around on its base, and then he could I guess he could control whether it was on or off. And he had these awesome like sort of spirography almost on a dome kind of things going on. Pretty cool. And I found those were like the best one. Oh, and then there was a guy who was getting like pretty damn good fidelity using. So what's happening here is he's got a servo here and a cable to the spray can and a servo here, and so he does the triangulation to figure out like what lengths of I think he's using timing belt will get him to the right point. So there was a guy who had done essentially the same thing, but he's not against the wall. He's just like in free space, and it was set up about this big, so you could do it like in a doorway or something like that. And he had painted like a pretty impressive Coca-Cola bottle. So instead of the spray can, he had like a RGB LED like I have, and was getting like way better results in terms of like, is the pixel where I want the pixel to be? So I'm not the only crazy one. That's all I got. All the code is on GitHub. What did I do? We'll put it there. GitHub. I am shove media everywhere, which means that I am shove media on GitHub. It's going to think about whether it's going to load that. And per usual, there is no documentation.
Well, you are a developer.
Exactly. So that's all I got.
The tests are in there too.
All of them.
Every last one of them. If you want to hear my entire vocabulary of swear words, we can talk about. I've ever heard people talk. There's like a lot of people talking Angular in the room. Yeah, good times.
Oh, you like Angular too?
I love it so much.
All right, and one last thing, Terry. Once again, the Swag Bandit. So we've got Anything these out, right?
Do whatever you want with them.
All right. Well, I'll take them all, actually. So we have, I don't know if anybody's used the Johnny 5 stuff.
Yeah.
But we have 3 Johnny 5 t-shirts. Unfortunately, only 1 extra large. I always try to do my raffle. I'm going to try it one more time. I'm going to